Okay, once more time, good morning. This will be the last workshop for this Inventor Professional Workshop Series. And then component generation, or more specific, frame generation, as well as the design accelerator that available in Inventor. Okay, these two features, basically they are the so-called greatest advantage or the unique features that Inventor can offer compared to the other CAD software. We all know that CAD software, 3D modeling, somehow, somewhere, a lot of features more or less the same. We will start sketching, we're going to do extrude, we're going to do revolve. Those are basic CAD software definitely have. But to make a software so-called different from another one, they surely will have their unique features. Okay, component generation and also design accelerator is one of the features, special features or unique features that Inventor offer. Okay, so people choose between an Inventor or SolidWorks or Creo, CATIA, or Space Clamp or all those. They compare some of these features. So that's why today what you see over here may not be the full package of these two libraries, but at least you have an idea what Inventor basically is offering during the design, how it help you so-called model in a more effective or more efficient manner, or it doesn't. Okay, so that will be the things we definitely can see it over here. Okay, this will be the agenda for today, this 2 hours workshop. Component generation, there is a lot of component we can generate, but frame generation will be very important, as well as to understand the unique features Inventor Professional can offer. Okay, I will also demonstrate the weldment. I already know that, I know that last week, weldment is already demonstrated. Okay, but in frame generation, so I would like to do that again because you generate the frame, the structure, that include weldment, they are like a whole package. So that's why I will make a very short moment, a short time, just to let you all see how to make the weldment in the frame after you generate by the system. Okay, and after that, we move into the next topic that will be the design accelerator. Now, design accelerator in Inventor, they really have a lot. Okay, all those standard parts, they might generate more than just shaft and also bearing. Some other things like gear, power transmission, and other things, they are also available. But to do all those things, definitely it's going to take a very long time for it, especially like we want to use the split gear design to design the power transmission system. So it will be a very long hours. So the basic idea will be demonstrate over here today, how we make use design accelerator, okay, for import shaft and bearing so that it can speed up your design, because shaft bearing in mechanical design, they are kind of common. In mechanical design, any system, you cannot run away, you will have shaft. You cannot run away, then you have shaft, then you have bearing. Okay, but we don't want to design, you don't want to model bearing, we don't want to model shaft, which is quite repetitive. So how we make use of it? Okay, that Inventor this design accelerator offer to us. Okay, so we will start from here. And again, if you go to your Microsoft Teams, the workshop, I already uploaded, of course, this workshop slide, and as well as the model that we need to use over here. Okay, sorry, I think I forgot one more model. Okay, so let me just upload one more here. We need to have 2. Okay, just give me one moment. Okay, so I will upload one more part. Okay, so we have two parts over here. Okay, download it. Okay, download it. Then later we are going to use this tool to perform the agenda today. Okay, so I will switch to my Inventor. Okay, as usual, we are going to create a new project. Okay, we're going to create a new project. Hey, sorry. Okay, we're going to create a new project. Then we name it chapter 4, so that we can drop all the file that we are having over there. Of course, this is just my encouragement. If let's say you feel that everything you need to put into one project, I mean, there's no problem as well. Okay, so I will, make another new folder. What am I doing? Okay, so at D drive, okay, I'll make a new folder. So I'll name it a workshop. Okay, so I have chapter 4. Okay, and then definitely you must know the location of it, and you can drop, okay, the file into it. Okay, just give you 1-2 minutes of that. Okay, I have dropped the file into my project already. And if now I switch to my project, chapter 4, and I open it, then I surely will be, okay, seeing the two files that I uploaded. We start from the 3D sketch skeleton V1 first. This 3D sketch will be just serve as a sample. Later we will do it. Okay. Later we will do something like that. Okay, I will open the 3D sketch skeleton first. Okay, so everybody have this. So now if you try to rotate, okay, this sketch, you find that they are like a skeleton frame. Normally, if we are talking about sketching, they are on 2D. Like on a piece of paper, you do sketching. Okay, when the time we start a 2D sketch. But we all know that when we click the drop down on the sketching, we also see 3D sketch over there. Now, 3D sketch, they will not limited by the plan. You will not necessary to choose you want to sketch on XY plan, YZ plan, or the other plan. Okay, so now, for example, so later we're going to model this. So it's very simple. Okay, 2,000, 1,000, and also 500. So now you just open together with me matrix standard part file first. Okay, so now you just open a new matrix standard part file together with me first. We are going to do this 3D sketching, which is fairly simple. Okay, so use yeah. Okay, and then I will switch it to my home screen first. Okay, so a new part. Okay, so now if you start normal 2D sketch, they will ask you to choose a plan for you to sketch on, and the plan must be flat. If you don't have a flat plan, then you will create your own work plan and do the sketching. That is the normal practice for any CAD software. Okay, but 3D sketch, then we need not to select. So now we turn to 3D sketch. Now, when the time you see that you activate 3D sketch, okay, that you see it over there. They did not ask you to choose any plan to do the sketching. Okay, but instead of that, let's say I start a line. Now I'm in the 3D sketch. I hope that you're also in your 3D sketch. Okay, so now the line, if you click, so they will come out this icon. Okay, they will come out this icon. So this icon, if you try to move, okay, no matter how you zoom, the icon will not get bigger. Okay, no matter how you zoom, the icon will not get bigger. So this one is just guiding for you. You can freely do sketching in the 3D environment. That's mean X, Y, Z, which direction you want to go is completely okay. Okay. So frame, if you want to generate frame, 3D sketch is a must as the starting. Now we're preparing, we are doing 3D sketch. It is to prepare to do the frame generator. Okay, or to generate the frame in the Inventor. I know 3D sketch, other CAD software also available for their own purpose. Okay, but here this will be for frame generator. Now let's say I will start from the black dot over there, which is the center point. Okay, when I click, now I can create a line on the X direction, or the Y direction, or the Z direction. I just move my mouse on it. Okay, so now let's say I want to generate a box, like the skeleton box or the skeleton frame, like just now I'm showing in our 3D sketch skeleton, we want that file. So I will be going to the X direction first. Of course, you can go other direction. Okay, but choose one. Okay, choose one. So now let's say I will follow the line. You can see that on the X direction. Now I key in 1,000. Okay, so now you see. And I give a home button. So now when the time I draw 1,000, I key 1,000, right? So this icon that you can see over there, this icon that you see over there, they will from here, and then they will come to here. That means I created the line. Okay, I created the line. Okay, in this manner. But if you don't press escape, you will continue to do the line. Okay, you can continue to do the line. So now I will continue. Of course, not necessarily it will be just like a so-called pure vertical. You actually still can move a little bit. Okay, by pressing Control. If you are pressing Control, then you will find that they are freely moving your 3D. But this will be very dangerous because they are 3D. So this means they can go any direction for your endpoint. Okay, so that's why in 3D Sketch, even though this feature is available, very seldom I'm using it. So now I release my Control button. And now it will follow the exit again. Okay, so no problem. You can even select the plan to a further guide. You just want to sketch on that plan, but they're still 3D. Okay, they're still 3D. Now, let's say I will have one up, that is 500. Okay, so home button. So 1000, we know that there's 1000. If let's say you don't want to key 1000, you can come to the endpoint here, just touch, and then slowly move. Okay. Okay, let's do it again. Okay, so it doesn't show that. Okay, never mind, we just key 1000. Okay, and then I will get back, snap back to the endpoint of the line over there. So now I can see that I have a frame, but I can continue. Now I will continue on the Z direction. I did not press escape. Okay, I did not press escape. So I can continue. So now I continue to another direction. You can see that I am not limited by the plan. I'm not just doing the sketching on the X, Y plan. Now I go Z direction, and the sketching line is continue. Okay, the sketching line continue. If you're doing normal 2D sketch, the sketch on this plan and the sketch on another plan, they cannot associate. Okay, if you're using 2D. But in 3D, then we can have all the sketch different plan, they are together and associate. Okay, so now I have another 500 on the Z direction. Okay, and then here again, on my X, I want to have 1000 over there. Of course, now I key in the dimension. You can do the dimension later, also no problem. Okay, so now I have nowhere to go already. Okay, I don't want to overlap, so I can escape. I can escape. Now this one like 3D. Okay, but even though it's 3D sketch, we are still in the sketching mode. Okay, we are still in the sketching mode. So I can continue. Okay, I can continue. Now I still in the sketching mode. I can continue the line. Now I would like to start the line from here. And then move up. 500 also. Okay. And then connect it and then escape. So now I can do that. I think the concept is clear. Okay, and then I will finish connect it. Now I have a skeleton frame using 3D sketch. And I can, of course, redimension it. Now let's say this one is 1000, the width. So I can continue to change it, no problem. So, okay. And then this one, let's say it is 2000. Okay, further. Modify it. If let's say they modify in this way, so-called, let's say they are like running a little bit. So it's okay. So we just change because some of those that we need. Okay, all we need to do is, if let's say you can see that they are like go a little bit haywire already. But if you change all the dimension that you put in accordingly, then definitely they will get back. So you don't need to feel panic. Okay, because every line that we also key the dimension. Okay, every line we also key the dimension. So if you change the dimension accordingly, so that shouldn't be any problem. Now, 3D sketch really require your good so-called imagination, or you're very sensitive in the rotation space and all those. Okay, if no, then sometimes you may mess up the things. Okay, but once you get used to it, they are very useful. Okay, so I hope that you can get the skeleton using the 3D sketch over here. If somehow you still cannot get it, but you know you almost want to get it already, you can practice it later, and you can still use the 3D sketch skeleton V1 for the exercise of frame generator. Okay, so this is how we using 3D sketch to do the skeleton development or modeling. Okay, so if you're working on that, I'll give you 1-2 minutes just to finish up your skeleton. And of course, after you finish, remember you are still in the sketching mode whereby you cannot save. Okay, you need to finish sketching, then you can save. Okay, so I will say this is V2. I know they are the same thing, but I just want to distinguish them. Okay, so now I just use one. Okay, if you have to use the one that you just established, there's you can use that, but we just use one of. Always check after you do the skeleton using the 3D sketch. See the endpoint, are they correctly snapped? Because 3D do have issue sometimes in snapping the endpoint. Not the software issue, it is our eyeball issue. So that's why be very careful on that. And normally 3D sketching, the whole frame, they are movable because you may not able to snap at any plane or the center point. Even though I try to, okay, now let's say for example, I know that there's a center point. I try to snap it together. Okay, but you find that no. Okay, there's nothing for you to do that. Okay, so they're a little bit special in 3D sketching. Okay, but that will be okay. So, I mean, this will be the only sketch that I can accept. They are not fully constrained. If it's 2D, then it must be fully constrained for a healthy practice in CAD modeling. Okay, if some of you just join in, you can go to the Microsoft team. Okay, Microsoft team. You can download the. Okay, you can download at the chapter 4 model. Okay, use this tool. Okay, so save sometimes, even though you did not doing the 3D sketch, but you can still follow the lesson. Okay. So now I just close one. I'll just open one. Okay. So I'll use save. So I use this same thing. Same thing. 2,000, 1,000 times 500. If you look at it, you feel that they are a little bit like, is it 90 degree or not? Okay, you can always dimension. Okay, you can always dimension. No issue. But if you put a dimension, maybe okay, not a lot over. Okay, but at least you will be seeing that. Oh, that's 90. Okay. So now I would like to generate the frame. Okay, what is the frame that we talk about over here? Okay, 3D sketch, no issue. Now this is the frame that we want to generate. You can see that for frame structural design, frame is common. If we model it, that will be very tiring because the profile of the frame normally is very consistent. There may be a L shape, there might be a hollow tube, there might be whatever it is. And they have their standard. Okay, we cannot simply just have our own way. Okay, they have their standard. But all the frame, they come together and then definitely we will weld it. In 3D model, they'll be very tiring. They'll be very tiring to do that. But it's necessary to do so. Why? Because the closing, okay, especially on the edge of the closing, we call how it is, the biggest issue will be here. The frame, all this, how you want to put them together, no issue. But here, how you want to connect them, become a big issue. Become a big issue. So 3D model is one to talk about that. But to do that, they'll be very tight. So that's why if we are using frame generator in the Inventor, then this will be greatly, of course, a feature that will greatly enhance our efficiency in doing this type of design. Okay, so that will be the purpose right now, what we want to do. But generate the frame, you can see that there are more than one part. So they are definitely not Inventor part, they are Inventor assembly. Okay, that Inventor assembly. We need to have an assembly environment to contain them. So now if I created my frame under part, you can see this part, right? Okay, you can see this part IPT. Okay, that's part. So I have to open a new, okay, assembly over there. Can use MM here. We can choose Wellman like last week, how we did that. But we can also choose standard first, later can convert it to become Wellman. Okay, no issue. But normally frame, we will start with Wellman. That is kind of so-called common over there. Okay, but I just want to demonstrate that later on. So that's why we choose the standard MM in the assembly. We'll create one first. Okay, and create one. So now if let's say I put them side by side. Oh, this one I don't need. Okay, one more time. If I put them side by side. Okay, this is my frame. This is my assembly. So I think that is very clear. You can see that. So I drop my skeleton into the assembly. Okay, I drop my skeleton to the assembly. And of course, you can rotate it to the view that you want first. And then later we can set the new. Okay, so a little bit easier, actually, if you look at that. Okay. So now I arrange it this way, and this I'm going to set it as my new home view. So now if I rotate it, F6, it will bring me in this orientation. Okay, in the assembly, they'll be always good. You set your home view that you feel comfortable for you to do the assembly. Okay, and that's not difficult. Okay, and then after that, in my assembly, I save it first. Okay, save it as this one. It is the frame generation. Okay, save your assembly as the frame generation. Okay, if you have done this, this skeleton basically is already fulfilled his duty. So just close it. Okay, and this is my assembly. This is my assembly. But if you say you still want it to be open for any purpose, then I mean, no issue. Okay, you can still open it. Okay, this skeleton you can treat it like a part, even though they are not a part, they are just having some line. Okay, you can still open them. So they are there. Okay, if you want to. Okay, but we're back to our assembly. Now you can see this one part. Okay, this one part. The first one drop in, they will be grounded automatically. That's what I did mention to all of you. Okay, so now we are going to start to do the frame generation. And all you need to do is under assembly, you will be seeing that there is a design over there. Okay, there will be a design over there. Or under environment, we can also use somewhere over here. Or environment, no, okay. You only can analyze the frame. Okay, we back to design. Okay, you'll be seeing that there will be the frame. Okay, the section over there. Okay, if no, if let's say yours one is disappear, then you will see there's a drop down list over there. Maybe you just did not check it. They did not see it. Okay, so all you need to do is open the drop down list and check frame. Then you will have the frame generation one. Today we will do frame generation, but we don't do the analysis yet. The analysis in the future, maybe we will do that. Okay, if you're still interested on Inventor, okay, over SolidWorks. Okay, and then we are going to use later the design accelerator, whereby they are here, the power transmission, all those things, or even some other things. So you can see that under design, they have so many things basically we can use to speed up our design. Okay, but they are really huge things. So later we are going to do this, and then we are going to do shaft and also barrel. Okay, how to insert. Okay, so now we will insert the frame based on this skeleton. Now, when the time you call insert frame, okay, you can select a line first. Okay, now I select this line. Now you'll be seeing that follow that line, they've created a frame for me. Very convenient, right? Okay, don't care about how they join first. Okay, later we are going to adjust that. But now you will see that select the line. They'll be helping us very fast to generate the frame. Okay, so now I just select all the line first. If let's say you want to deselect, okay, just pressing Control, and then highlight it, then you deselect. Why? Because you can select the other frame, the same frame under the same skeleton, but we don't want to make the things too complicated. Okay, so today we just use the same frame. Okay, you can adjust or select the frame. Now you can see this frame, it is a hollow rectangle. And you can choose your frame over here. Beside the material and all these things, the sizing you can change. But another thing is, of course, the style of the frame also can change. Okay, make sure that that is the standard that you want. Let's say, for example, now I'm using ISO. Now you see that ISO, the first one is tube. Okay, so you can choose the other, but they did not preview. They are standard. I already said that the frame, international standard, they have their standard part. So For a mature engineer, then definitely they will know that code is referring to what. But even you are not, then it's all right. Today, Google is so powerful. You look at the code, you Google it, you get it. Okay, for example, now I just want so-called not a flat bar. Okay, then I just say that there is a hollow section. I choose that, then you can see that. But this is square. Okay, this is square. You can try other things. Okay, that is available. Even the L shape. Okay, also is possible. Okay, but I don't want to overdo. I will make a square for a simple demonstration for today. And here's the sizing. It is square, and then you can adjust the sizing under the same category. Okay, now let's say I want 50-50. Okay, for example. So now it can be. Material, of course, you can choose. Okay. If let's say you want to adjust the degree, this one very rare, but it is possible. So if you type 30, so you can see the frame, they are rotating. Okay, but I don't need that. But even offset, if let's say you don't want them to join that way, say offset 20, so you can see that. Adjustment. But now I think everything back to original, that would be just nice. And now we use ISO square. Use square first, okay, for a simple starting to learn the frame generator. Okay, whatever standard that you choose right now, choose the square one. Okay, and then select. Okay, select all the select all the underline. Okay, so now I'm having all already, and I'm very happy with it. Yeah, I'm very happy with it, even though the join is not complete yet, but okay, and then I click OK. Now, when the time you click OK, they will telling you that they are going to generate the frame, and all those frames are an individual part. That means here we are going to generate how many individual parts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, because they are not coming from the air, okay, dropping from the sky, no, they are generated. So now they will telling you that you are going to generate those parts under your project. So you can see that. So that's why select project. Again, I want to emphasize that you create project, select project is so important. Okay, it is so important over here. So now I will click OK. And then you'll be seeing that because I have multiple monitor, so they jump into another monitor. So now this is what I selected, and then this is what they are going to generate for us. So 12 of it. So click OK. And now I select, I have my frame. Okay, and you can save yes all. Okay, save it. Oops. Sorry. Okay, if you already generated this, you try to observe your project folder. You did not see that frame, right? But you will see there's a folder there. Okay, you will see that folder there. Just now it will be just your file, your project, okay, your assembly and all those things. But after you generate the frame, you see that there will be a folder there. And you open it, basically all the part is over there. Okay, all the part is over there. Okay, all the frame. Okay, the 12 frame. And the other, of course, for their reference for the system. But your frame is here. Okay, each of the frame is here. Okay, so they are under that folder. Now I don't want to look at all this dimension, which is my 3D sketch. Now you see that one is the frame, but in the assembly they are like sub-assembly. They are one. Okay, but you can open them. You can see that each frame they are just one part. But now I don't want to see my dimension, which is from the 3D sketch skeleton. So here Okay, here this I open and I would like to turn off the visibility of the 3D sketch under the 3D sketch skeleton part. I don't want to see that, so I just turn it off. So I will only have the view of it over here. So now you can see that from 3D sketching, put into the assembly, and then use the frame generator, that is very fast. You try to imagine if you're going to do this 3D model and then make a profile and then put them together and join them, that will be a huge work. But your company need that because it is the design. So without these features, then this work will be very time consuming. But right now, you can see that we are one click, then we have it. Provided you know that what frame that you want in your design. Okay, sometimes it's just the engineer don't know what frame they want. Okay, they may have it, but they don't know the standard. So they look into the library, then they search and search and search. But frame can be customized, not necessarily just from the library. But that's another topic already. Okay, so after we do the frame, the next thing very important in the frame generator is you look at all the joint. They are definitely is overlapping and not complete. Okay, you can see all the four, so the 8 corners joint, they are overlapping and not complete. Now, if we are doing manufacturing for the frame, this we need to trim them. Okay, we need to trim them. And here we can also do it. Okay, under the 3D, sorry, under the design, just not only insert frame, but once you insert other features, open. Okay, other features open. So we do a very simple one. Okay, how to close this is using the meter. Okay, how to, you can see the preview picture over there. How we going to use an intelligent way to make the joint according to our preference. Okay, we turn that on. Now, the first is you'll be seeing that what type of so-called frame you would like to have. Okay, normally this one is very common. Okay, how to do so? So now I just select. Okay, I just select this and this. So now once you select, then you'll be seeing that how they join. Okay, they already previewed to you how they join. Of course, you can pick some gap over there. For example, let's say you want welding. Okay, you want to do a field welding. Yeah, okay, you can get some gap over there in the design. And let's say you don't want, then not right now we just do modeling, then we just leave it. Okay, so there will be things. If let's say you select one more member, then 3, right? So now you can see that they will be help us close beautifully. They will help us to close beautifully. And we don't need to do calculation. Later on in the technical drawing, we can just bring out this and then do dimension. We don't need to do the calculation. They will help us to do that. If not, click OK. So now you can see that they close very beautifully. Okay, it's very beautiful. Okay, so now I will do it for the other 4 corners on top first. Later we talk about the other type pattern for the bottom. So now you can exercise this using meter. Just select this 3 frame. That's all. Okay, so close it for your own model. And then remember after that to save it. Okay. That's for the top one. Okay, that's for the top one. Okay, perfect, beautiful. Okay, so now at the bottom, we try another pattern. So now I will also use meter just to join the bottom. Okay, just to join the bottom over there. This one I know is overlapping, but I just leave it. Okay, I just leave it. Now I only join. I only close these two. So this one I only close this and also this. This is still overlapping. Okay. I don't want just like the top one, they are like pyramid. I want some other things. Okay, I want some other things. So I join these two first. Okay. And then now let's say example, you use meter again to select. You still can get back that. Okay, that's one of the things. Okay, that's one of the things. But now let's say your boss saying that the bottom one, we don't want to do that. That's not stable. Can we just trim? Can we just trim? That means the overlap, just trim and then nicely they lay on it. Okay, over there. For example, that's what this one they trim. And then the frame will be just stay over here, and then later we just do some. Okay, we just do some welding. Okay, over there. Okay, so of course it is possible. Okay, of course it's possible. So you can see that over here, they will have a notch. If you look at it. Okay, the notch. Now we don't have the notch, but the notch is part of the frame. You can see that. Okay, you can see that. Now we try this one first. Okay, you click on the notch. Okay, so you look at the color represent, then roughly you know. Okay, so member notch tools. So now let's say I say that member is this. Okay, these two member. Notch tools will be this. So now if you're using this, you can see that they will be, the tools will be like, I will stay there, whoever at my way will be trimmed. Okay, you see the things. The tools is mean that whoever I will not tolerate, they will be saying that whoever that is at my way, they will be gone. Okay, so if you're doing this, then of course, if you click OK, then you'll be seeing that. Okay, then you'll be seeing that how actually they cut the things. And then my frame, that will be retained over there. Okay, it will retain over there. There's the notch. Of course, now I control Z, undo it. Turn it one more time. So you can say that member can be this. And then tools, because tools will say back, can I use the bottom as the tools? That's also the way I reverse it. Select this. And then the tools, I'm going to select this. Okay. Okay, now, because the yellow color is tools, the bottom one, they will stay back. The blue color will be trim. So now I can see that. Okay, okay, so now they will be trim. Okay, they will trim. But when the time they trim, they are nicely closed. Okay, they are nicely closing it. Okay, they're nicely closing the things. So there is notch over there. Of course, we might be asking the question, in manufacturing, the production, can they do this? That's not our issue. Okay, we are doing design. Okay, can they do that? Can they have the tools? Then you need to ask your company, do you have the tools to close this? Okay, so there is the notch. So I control Z again. Okay, another way you want to do, you can do the trim. Okay, you can do the trim. Trim actually is like the things, tools again, and also member, like the notch. But this one is they just simply cut the things. For example, now the tools, now you know what is the meaning of tools. So the tools is this face. Oops, sorry. Okay, one more time. Okay. The tools is this face. So that means that face is going to help me to do the things. And this, remember, I'm going to have this. So now you can see that they help me to cut. Okay, tools is the cutting reference. But you can see that when they cut, they just help me to nicely cut flat. They did not help me to close very nice. You can see that there are some called opening. Just now I use notch. They help me to close nicely. So now I click OK, and you will see that. Now you can see that. See that now they are just really laying over there. Okay, now this will be depend. Okay, now this will be depend on what the company of you, the technology and the technique that is available. Okay, so now I just use trim. Okay, now I just use trim for the other four corner. You can use notch, no problem. Okay, you can use notch, no problem. I just use trim. Okay, I'll select that face. Select this. Okay. The same thing. If you want to use a short key, okay, too bad this one don't have a short key, but we can create short key. But again, there's another story. So now you can see that. Oh, this I haven't closed them yet. Oh, this one I haven't do the meter yet. Okay, so now we do like an exercise. So we meter all these first. And after that, we trim the top one. Okay. So I think this one I also haven't do the meter. But I already do the trim, that is okay. Because trim, they just cut. So now we do the trim again. Tools, member. Okay, even the top and the bottom is different, but the design is a little bit logic because the bottom, it might need to support things. So in this design, they might be slightly stable instead of this. Okay, so this close, and another type of closing. Okay, you can try it on your frame, but for the 3D sketch, from the 3D sketch until right now, what I did for the frame, you can see that within 1 hour, I finished design my frame. Okay, I finished design my frame. And all the cutting, everything, I calculated it nicely already. If you want to go drawing, for example, I want to put this in a part of it. Okay, I open, for example, I just open one. You can see that this will be nicely being cut. Okay. Technical drawing, how you want to do them, of course, that is upon your how well are you doing the technical drawing, okay, 2D. But the thing help us speed up our work is we doesn't need to calculate this cutting already. Okay. We no need to calculate this cutting. This whole frame, if you put into the assembly drawing, the part list, they will auto-generate for all this frame. Okay. When you have any issue on the first part, not the first part, basically for the first session, okay, in the workshop today, that is the frame generator. Very fast, very easier. And this one can do FEA or stress analysis. We do that in the future. Okay. Okay, I give 1-2 minutes for this. Then later on, we will use this to do our design accelerator, how to insert shaft and also the bearing accordingly. Okay, if no issue, then if let's say you want to include welding, like last week, the information with weldment, so you basically can come to the environment and saying that I want to convert it to become weldment. Because in the beginning here, if you did not select weldment, remember, weldment, they need to have a weldment features. But now they don't have because we choose standard. But we can convert. Okay, we can convert. So now I just try to convert. Okay. Say yes. So let's say I choose ISO. So now I can see that the Wellman features it is appear. Okay, and now we also have the Wellman features at our tag. Okay, we can do something like last time or like the last lesson. So we can just do the well, okay, and then let's say I use this. So I will just select the face that I would like to have. Oops, sorry. There's only one face here. Select the face. Okay, one face, another face. So now I can see that I have the realm. Okay, so this one I think last week. If some of you missed last week the workshop, you can review the video. So now I have putting that. Okay, and you can do it for the others also. Okay, for example, now let's say I use roof. Okay, so the face that is open. So oops, I think I just do it too fast. I mean, but I think here, let's say we want to use roof, I think another calculation there. I just want to make it fast first. Okay. Okay. So you can do it for the others. Okay, detail about the Wellman environment. Last week, the workshop, we talked about that. Okay, included how to generate the simple and other accordingly. Okay, so I wrote that. So now frame, include the frame, the design, and then to close the end and do the trimming. And after that, we want to tell the technician or the manufacturing engineer, say that you weld here and you do the welding here, and then okay, other things accordingly. Yeah, just do one section. So if let's say in the real, then you have to do every part of it. Okay, so now I complete the first session of the frame generation, included the weldment. Okay, if let's say no questions, we will enter the second session, design accelerator. That is how we insert shaft and also bearing intelligent way. Not say totally intelligent, still need some engineering knowledge, okay, over there. But now I would like you all to open the part that I have sent to all of you. There is another part called the frame design accelerator. Just a frame on it. Okay, just open it. Okay, just open it. How to do this? I mean, how to model this frame, I think will not be any issue to all of you. So that's why I don't want to spend time just model this thing, okay? Just to pass it to all of you. Yeah, I just try to measure using M, okay, 90, and then let's say this is 75, and then the distance, and the distance is 15 diameter, and also the distance is 800 mm. Okay, So 500. So just nice. Okay, so I don't want this already. So now I'm having my part and also this. So now we are going to insert our frame design accelerator into the frame generation assembly. Okay, so again, I will put them into side by side. Okay, of course, I know that you want to place it. Okay, and to place it as normal way, also no problem. Okay, but I think it will be more intuitive. We have all the part and then we put them like in the real life. Okay, how we take all the part and then we join them. Okay, in front of us. So in the virtual environment, personally, I also enjoy doing so. Okay. So now I have this frame, and I'm going to drop it and drop two. Okay, drop two over there. Okay, this one don't close. Don't close. Huh? We need this again. Okay. So now I want to assemble it on my frame. Okay, I want to assemble it on my frame. These two parts. Now, together with me over here is I want to drill a hole on this and also this part, the frame. Okay, now it is another demonstration how we can individually modify the frame. To drill a hole on the frame is very common, right? So that's why we need to know how to do that. So, but my all my frame is grouped under this features tree. So I open it, you don't know which one is which one. But when the time you just move your mouse there, basically you will know. Just move your mouse, no need to click. Okay, so now I would like to have that frame. Okay, this one I know. Okay, and then you right click, you edit. You right click and then you edit. Okay, you right click and then you edit. And now I want to drill a hole on it. Okay, I want to drill a hole on this. So first it is, of course, I will start the sketching. No 3D sketch, 2D sketch. Okay, I want to do a sketching on this face. Okay, I would like to drop the point. Okay, over there, 2 point. So to dimension them, I just create a line and then turn on construction. Okay, turn on the construction line over there, and we know that they already give me the midpoint there. So I draw a line, a straight line. Okay, a straight line, but it's a construction line or the hidden line because I turn on this. I don't want it to be solid line because I don't want to use it. I just want it to be a reference. Okay, so all these points I drop. First, I will put them. Okay, I will put them over there so that they will be at this line. And then after that, I put the distance of them. Just now we know that they are 800 in between. Okay, this and this. We just already measure, right? It's 800. So now I want this also should be 800. Okay. And then the distance. Okay, the distance I will also create one more line. Okay, that is there, so that I can position the distance. Okay, maybe this one I just give it 150. It's too less. Okay, 300. Okay, so I finish. Now you know why I create the hole. Sorry, the point, because I want to drill a hole using the hole features. Oh. Okay. So now I finish the sketch on it, just like normal part modeling on it. So I create the hole. Okay, over there. So it's too huge, 90. Okay, so now I just want to have 15. Because just now we know that it's 15. If you're not very sure, okay, you can go and measure again. Okay, but I think it's 15. Okay. So 15 diameter. So now here I will do that again. So 15. So drill it through all the way. So now I have that drilling hole on my frame. And I click return. So now back to assembly. Now you can see that only this frame, okay, only this frame they are having the two over. Okay, I will do that on another side. Now the tedious thing is we need to do it, okay, on the frame that you want. So now I will also do that. I'll do it fast. Construction line. Okay, then I will drop the point. Put them on the line. Position them 800. And then I also draw a line here to position it. Remember, construction line. So that they will match to the opposite. Okay. So that later they can match with this. So that's what I follow. Okay, I finish and then I will use the hole and then same 15. Okay, so now I also drill a hole. So let's say I click with front, then I will be seeing that it is matching with the opposite one. If it's not matching, that's when you will see some overlapping. Okay, but now you can see that it is matched. Okay, that's why I can see through. Now I have drill a hole on my frame. And then because I drill a hole, then it will be okay for me to assemble them on the frame over there. Okay, save first. So I give just for 1 minute. If let's say you are still drilling the hole, then just complete them. And then if you already complete, you can just assemble it. Okay, you can just assemble it on the frame. Okay, on your structure. Okay, the frame on the structure over there. Okay, just 1 minute for this. Okay, so I will put them now. I use constraint. Okay, first thing first is I will make this face stick with the structure first. Okay, I'll use this to stick them. And next is the mechanical hole and the mechanical hole need to be aligned. So I will select this and this. So now they will align. And of course, if you only do this, you find that they are just only hanging halfway. Okay, so then I will align them again. So now that is complete. Okay, that's complete. So let's do for another side. Okay, do the same way for another side of it. Okay, so try to adjust, open, and then put them together. So now everything is fixed. Okay, everything is fixed. And we are kind of ready to insert the shaft and also the bearing accordingly. Okay, so without any further ado, now we go to Design tab. First, I want to insert the shaft. And my shaft, of course, must have bearing, but I will insert my shaft first. Okay, I will insert my shaft first. There's a reason why. Okay, I want to design a shaft that is the connection of these two holes and as well as these two. Okay, so just do a quick measuring. This hole is 90 diameter. Of course, the another side, of course, the same now. Okay, so because they are the same part. So now I will click on the shaft. Now I can see that when I click shaft, they already immediately bring out one. Okay, they immediately bring out one for you. And all we need to do is just to place them where you want. You can always click preview, look at the picture, then roughly you will know, okay, where you want to place them and how to place them. So the first one is to place the cylindrical face. So I want it to fix this hole, so I will going to click and then select that cylindrical face. So next they ask us to select, okay, the measuring face. Okay, they must be measured, okay, the distance of it. So I will be putting this face. Okay, and then the third is they say the orientation. Orientation is for keyway. Okay, for keyway. So normally I will use the top, okay, 90 degree of the face as my measuring reference. So now if I put that, you can see that now I have my shaft there. My shaft. A very rough way first. Okay, a very rough way. But you can see that now we no need to do all those measuring. Okay. So we're having that. Okay, first it is, you can see that the shaft, they will be allow you to customize how many steps you want. By default, they give you 2 or 3. But let's say I delete this. So now this is one section, this is another section. You can see that. Okay. So now let's say you want, there's one more section. Okay, so then you need to add. Okay, then there will be one more section. Let me see. Okay, and you can adjust the sizing or the length of it, just tracking the error first. Okay, just tracking the error. And this also, I can change a little bit. But now this, if you change, okay, if you try to change, they are just moving the whole things. Oh, sorry. Don't press escape. Okay, don't press escape. So now I'll do it one more time. Oh, I think this, later I'll fix this. Okay, this one. Maybe I just fix it first. Sorry. Press escape at the same time, also press Ctrl Z. So that's why it gone the things. So one more time. Okay, one more time. the design. So I will place that face, then the measuring face, the orientation face. So now I'm having that. So how many steps you want, that is depend on you. Okay, how many steps you want, that's depend on you. Okay, so now let's say I'm having this another step. So I want to modify the so-called the dimension. So you can click, okay, sorry, click this dot. So now you will be customize the things. I know that this is 90. And I definitely don't want my shaft 90. I want to insert my bearing later on. So you can insert the dimension that you want, okay, for the shaft diameter. Okay, so 90 and then 50. Okay, maybe now I put 60, for example. So now I can see that they enlarge. Okay, the length also you can. Now let's say I put it is 150. So now I can see that the length can be changed. Okay, accordingly over there. Okay. You want to move a little bit out? Okay, no problem. Dimension you can key in. But now I just do it freely. Okay. So just want to make it outside a little bit. Okay, roughly there. But of course, we can also turn it backward. Okay, and all this. We can do it very free. Okay, so that is the first step. Now the first step, what else actually you can have beside turning the things? It is you can add chamfer or fillet. Now let's say I add chamfer. So now you can see that they will help me to do the chamfer over there. Now let's say I say it's 2. So now I have a chamfer there. Okay, at the front. So you can also add another things at the back. So now I can see that this will be for this part, and then this will be for here. So now over there, the second part over there, I may not want a chamfer, I want fillet. Okay, I want fillet. So then I adjust the fillet like this. Example 5. Okay, I know I'm a little bit exaggerating, but I'm just putting. Okay, or other, okay, other groove or whatever, but I don't need that. Okay, if you want to add a keyway, then you can add a keyway. So you can see that everything is so intuitive. Now I will do it on my second part, the middle one. So the middle one, now I know that I don't want it to overlap. So the middle one, I can adjust the sizing back a little bit. Okay, of course you can do the sizing, okay, in this way. But now I just want to do it free, okay, for demonstration. So I'm doing that. But the diameter, okay, I would like to adjust a little bit. Might become just 70. So smaller. Okay, the length just now I freely move. Let's say I want 900, but I freely move cannot get it 900. So then I can also adjust it over here. Yeah. So now the features I also can add. Okay, they will always look from this side. So now the second step, no features, but I want to add a chamfer. So now I can see that they add a chamfer for me. Okay, so maybe I put in 1. Then okay. Another side, I also want a chamfer. Okay, I also make it 1. So then I've chamfered it. So now I can see that from this way, of course, very repetitive already every section. You can design your shaft very fast. Okay, you can design a shaft very fast and place them. Okay, you can place them over there. So now I'll do it for the last section for it. So now let's say this one, I give them 50. Okay, the length, okay. Then I also want it to have chamfer. Okay. But here it is fillet, so I want this fillet first. Because they are viewing actually from left to right. So that's why from left to right. So, okay, for the fillet. And then here I want a chamfer. That is very standard for a shaft. Okay, so now I make it 2. So If everything okay, if everything okay, then you can, let's say I want to enlarge it again, make it longer, okay. So make it a number, maybe just a nice number, okay. If everything okay, then you can click. If let's say you find that you still need some other things, for example, this one is very long, I want to create a keyway. Then you can add a keyway, okay, over there. Like I said, add a keyway over there. Of course, the keyway that you want to, okay, rotate them, okay. Because anywhere, like on the cylinder, right, anywhere also no problem. And now, let's say you just want it to nicely to be viewed. Yeah, I put 70. You can adjust it, the sizing of the keyway, up to you. Okay, up to you. Okay, you can also adjust the dimension. If let's say you don't want to drag. Okay, and then the distance and all those things. So now I just make it in this way. So I click OK. So now I generated. Okay, I generated my shaft. Okay, I think the key is at the bottom. Okay, the keyway is there. Okay, later we can adjust it also. Chamfer, the filler. So everything. If you model this one and then want to assemble it over in this environment, then it will be also very time consuming. But now I'm having this in a fast manner. Okay, but they're fixed. So you can see that shaft. You can always come back and delete, delete, to edit. Okay, and then to readjust the things again. Okay, so no problem. Okay, so maybe the angle, I just put it at 0. Okay. Now there. So adjust to the angle that you want so that they can see on top. Maybe I adjust it one more time so that I can see it on top. Okay, now it's on top. I know I need to adjust a little bit up because keyway over here is too close. So later, if I put in the gear there, then there will be have a collision over there. But this is how we can get our shaft very fast. And when you do dimension in the technical drawing, then you can bring them out already. Okay. Okay, so I will now insert the bearing. Okay, now you can see that there is a space for us to enter to insert the bearing. So now I will click on the bearing now. Before you adjust anything, we just telling them what size we want and where it is location. So cylindrical face, I will select that. I'm going to place it there. Okay, and then where is the face actually you would like to start to generate the bearing? I see that from this face. Okay, from the preview, I think you can see that already. Okay. And now, let's say you want to measure the sizing of it. Okay, so you can use measure. You don't need to key in. If let's say you want to key in, okay. But I want it fast. I don't want to do any calculation. So I measure. I measure from the face of the shaft. Yeah, for this shaft. And then 2 also measure. Okay, over there. Okay, so then I will have a reference over there. Okay, from here to there. Okay, from here to there. So now I click. Wait, before you click update, select the category, the bearing that you want. Okay, select the category of the bearing that you want. Now I just select all the category first. Okay, I just select all the category. And now they will be showing to us. Okay, if everything okay, already selected, they will be select all the bearing. Of course, now I select all the standard, right? So they're giving me all. That is suitable for my situation here. But now, if let's say I only want ISO, then you will see that ISO basically only have 4 is suitable. Okay, you can enlarge it. Okay, to see the things. So now I just limit myself ISO. So now you can basically say that I only want ISO. Okay, and then under ISO, all the bearing category, I don't want to specify anyone. I just want to list all the category of ISO to me. Okay, so okay, let's see. Oh, but they still give me all. Okay, maybe I just try ISO or and then ISO this. Now, okay, yeah. I need to select the ISO. Okay, I need to select the ISO. So or then they will give me ISO. This one is suitable. So then now under that, the dimension will be specific over there. Okay, select the one that you would like to have. But this one is standard again. This one is standard. They may not suit the size of the hole. Because the hole that we open can be free view. But the bearing standard, the dimension, of course, they already fixed. Okay, so like just now, we already know that the size of this hole is 90 mm. But here you can see that they don't have 90 mm, for example, in ISO. So then you may need to choose one is very close. For example, now I choose this one, 85. Okay, I choose this one is 85. Okay, okay. Now they generate a bearing for me. Okay, they generate a bearing for me. But this bearing is 85. Under ISO, they say they don't have 90. So then what I can do, because I know that this is 90. Sorry. This one is 90. Okay, and this bearing, again, edit. This bearing is 85. So then I have to go and change my design. Okay, I have to go and change my design and back to here. And this hole, I'm going to change it to become 85. If you want to use ISO, of course, other standard, they do have the other, they do have 90. But now back to here, you'll be seeing that I update. Now I can see it's fit. How they fit nicely over there. Okay, if you're not very sure, are they fit or not? So you can always inspect, see got interference or not. So now I will check interference with my bearing. Okay, no interference. So that's mean my shaft, my bearing fit into the frame nicely. Everything now is okay. Okay, so try to do another side for yourself. Okay, maybe use other standard. Okay, now this one is ISO. Let's say you say that, okay, now from another side. This one you can see that. I'm going to do that for this in the same way, insert the bearing, cylindrical face. Okay, and then starting measuring face from here. Okay, and then you can select. Now let's say I select all the standard, okay, all the bearing. There's too many of it. Okay, so okay, now, okay, so just now it hang. So I select all the bearing category, not just for ISO. So now they will be showing me all. Okay, I know that my one, again, I measure from this face to this face. Oops, sorry, measure again to this face. Oh, I already changed to 85 because they are the same. Okay, I already changed to 85. Okay, so now I have all the bearing. So you'll be seeing that. Okay. So you can select the one that you want. But because they are the same, so that's why if let's say you want to adjust, then that will be slightly difficult. Okay, so you can select. So now let's say I may not, because now my shaft, this one, the shaft, the size is different from the another one. So that's why the bearing they select for us also will be different. We may not have an 85 over here for this shaft, this small shaft enclosure. So that's why over here, normally we don't open all, okay, we limit. Okay, so now I become, and also another thing is don't use the same frame if let's say you are having different size of it. But now because I use the same frame. So that's why there I change 85 here also become 85. But let's say it's individual part, then no problem. So now just for demonstration purpose, I just select one that is 80. Okay, at least can fit in. Okay, select this one is 80. ISO, I know there's a 78, but let's say I just want to select 80. Okay, so maybe I select this. Okay, 80. And now careful on the preview. If let's say you see that they are outside, you need to flip them to insert them. Okay, flip them, insert them. Okay, so the list they give to us definitely can fit in the shaft. The shaft I just now adjust is 50, so that's why it's 50. So other than that, okay, so now I click. So I have 1 over. Okay, this one is 80. I know that the hole is 85. I don't want to change this hole to 85 because, sorry, to 80. If this one change 80, that also will, sorry, that will be also become 80. Because this frame and this frame are the same. But if we are using different frame, then okay. But this is how basically we can insert, okay, the bearing to it. Okay, if it's normal, then we may insert an O-ring just to fill in the gap. Okay, but now we're assuming that everything is good. Then now I'm having my shaft and my bearing nicely over there. Okay, that's it. So now you can see using design accelerator in the Inventor, even though now we're only talking about the shaft and also the bearing. Okay, but you can see how fast it is that we can do. And this one, let's say you want to open it individual, then you will have one. And this one, you can use it in your technical drawing and send it to the production. Ask them to produce this according to the dimension. Okay, over here. At the remaining time, if you are following over here, at the remaining time, you can do another shaft and the bearing insert, okay, for this hole. You don't insert the bearing first, because the bearing, they need to know, okay, the size of it. Unless you want to do that first, and then create the shaft based on the bearing that you want. Then you insert the bearing. Okay, so that's up to you, how you want to do the things. But just now I have the shaft first, then insert the bearing. Just for demonstration to you, how the intelligence search for the bearing that able to fit your situation, or very close to fit the situation. Okay, so that is how we can do. So in the remaining time, you can finish that connection, bearing, and also shaft accordingly over here. Okay, I'll give this to you. Maybe just 5 minutes or 10 minutes. Okay, you want to insert the bearing first? Insert the bearing first. You want to insert the shaft first? Insert the shaft first. Okay, no problem. Okay, if you have a question, you can raise it. Okay, I just try to do this. I insert the bearing first. Okay. So now the issue is, if let's say insert the bearing first, then this you need to know. Okay, you need to put in by yourself. They may not have it for us. Okay, so now let's say I select all. So they don't have that combination. So let's say I put 75. So that's why you can see that. Because you cannot measure, there's nothing for us to measure. If you have a shaft, then we can measure. But no, then you may be key manually, but they might not generate. Okay, so that's why I'm saying that put the shaft first, then you put the bearing. Okay, there's nothing they say that it is suitable. Okay, unless you want to simply just, okay, just want to simply put something, okay, but it won't be. So that's why I say that better create the shaft first. But do have a way you can put the bearing first. You can create a so-called a sketch, a whole, just a sketch for you to do a referencing. Sometimes people do that, like construction line over there. Okay, but now we just follow the standard way first. Okay, so I do that fast for one more round. Okay, like that. So this round, I don't need keyway. They are still memorizing what we are having, okay, for that shaft. So now I'm trying to adjust the size of it. And maybe this one, 50. Okay. Step and all those things maybe is still good to me. So this also put 50 so that later my bearing can be the same, fit in the same. Okay. Just make a quick one over there. So now, let's say you already get used to it. So I can see that now, basically, it's very fast to have a shaft. If your company already quite a standard, you know, the chamfer, what is the sizing, the filler, what is the sizing for the shaft, then every time you do the modeling, they already recorded. So every time you click the shaft, then you just put it there, then they are there. Okay. So now I can see that I already have the shaft, just a few clicks. And bearing. Okay, nicely fit in. So okay, let me select that. Okay, one. Why this one cannot change? So I do it one more time first. Oh, now it's back. Okay, so from here to here. Okay, now I generate. Okay, now I generate. Okay, select the one that you would like to have. Let's say you don't want the angular one, you just want a nice fit. So this round I select ANSYS. Okay, I'm gonna have one. Okay, that is suitable. Let's say that ANSYS looks okay, but let's say you say that it's still not that nice. Okay, again, you can choose the other. Okay, so okay, normally I will be choosing something like that. Okay, so let's see. Let's say you forgot what is the size of that. 75. Then okay. So I don't want angular. So okay, so you can choose accordingly. Okay, for the case over here, I may not have a 75 to fit in my shop over here. So I will choose one that is close. Let's say I put 70. Okay, so then later I can change. Okay, this will become 70. Okay, save it and then back over there, then they will nicely fit. Okay, so I will do that for another side also. Okay, nicely. Okay, I already changed to become 70. So now I have a lot. Actually, I can select. So now you can see that sometimes when doing design, we also need to follow the standard. Okay. Oh, forgot to flip. Okay, I forgot to flip. So now, done. Now you can see that very fast. We can finish all this design, putting all those standard part, as well as other things. If let's say, okay, we still have a few minutes, so I'll just finish this like this. Okay. If you're looking at this thing, we can also make use of our previous knowledge on the content center to fill in the whole button by you placing the bow and nut. So now let's say I perfect the things. I'm putting a bow there. Okay, just simply select one of it. So now I'm having that. Okay, so I can enlarge it because I want it to overlap. So they detect the hole, so now they will put that for me. Okay, now I can see. I do it from the other side. Because I want the nut, so that the bow are the same. So now I'm putting that. Okay, the bottom one, I say that, oh, that is not needed, right? Yeah, of course. So we can delete. We don't want to select one by one. We want them to delete for us. They want insert for us. Then we delete later. Will be easier. So now I put that, and then I will put the nuts. Okay, I'll put the nuts over there. For example, I'll put the hexagonal nuts. Just a very small one, okay. Will detect for me also. Okay, we do it one by one. So now I have that, and I will do that. Okay, so escape. So now I can see that my design is finished. Okay, I have the bow and the nuts to screw the things, and then I have my bearing fit in the size, and then after that I have the shaft over there. Of course, if we have time, we talk about the split gear, and then we insert the split gear over there, and then do the power transmission. That will be another very fun thing. But we don't have that time. But for an idea how to do the design using design accelerator, that I believe it will be sufficient and enough also. Okay, any questions? Okay, if no questions, so then I will stop the recording.